Wozniak once said, "Wherever smart people work, doors are unlocked." So let's just walk on through this unlocked door, shall we? Hey there, everybody. Welcome to episode number 519 of this here electronic engineering podcast called Amelia's Weekly Fish Fry. Brought to you by eejournal.com and written, produced, and hosted by yours truly, Amelia Dalton. What would our world look like without smart things? I shudder to think. My guest this week is Semir Haddad from MicroEJ, and we're discussing the biggest influences on embedded system development in 2023, the roles that servitization, containerization, and sustainability will play for the future of embedded system development, and how MicroEJ is furthering innovation in the world of smart things. Let's go. Hi, Semir. Thank you so much for joining me.
Okay, very good. Thank you, Amelia, for having me on this podcast.
Absolutely. Okay, so let's first talk about some upper level stuff. So, Semir, what do you see are the biggest influences on embedded systems development going into the next year?
Oh, yeah. Okay, 2023 will be certainly an interesting year. So some people would say, of course, the short-term influence that we see, like supply chain inflation, would be a big deal. But these are more like short-term issues. And what we see, in fact, is that more and more customers and more people in the embedded space are concerned with more longer-term issues that impact all of us. One of them, for instance, is sustainability. How to build sustainable product and how to meet all the pledges that everyone does. In fact, if you look at around us, all the major companies have made pledges about carbon reduction and greenhouse gas reduction. So it's a very big deal for everyone, and we see more and more coming to the embedded space and embedded people and embedded developers. And then the second trend that we think is going to happen in 2023, it has been a trend that was in the making for a long time, but now we really see it as reaching the shelves products and, let's say, really becoming the reality for all developers is servitization. What I mean by that is how people are turning products into services. So for instance, when you have a hardware product, the old model was you sell it and then you forget about it, and customer and the end user would just use it, and that's all. More and more we see developers and companies trying to bring some services into the products and making it more flexible, upgradable, and with a type of recurring model. So it's very interesting because for us as a software company, it's definitely something that we can enable. And the servitization requires lots of flexibility in the software development.
Okay, so Semir, let's talk about this servitization. How do you think it helps manufacturers of embedded systems?
Yeah, so for the manufacturers, it helps a great lot because they always have been looking for a way to generate recurring revenue. As I said, the old model for manufacturers was you sell a product and then you forget about it, and then you hope that your customer will buy another one later, try to improve it, that's all. But you lose sight of the product. With servitization comes many benefits. The first benefit is that you keep the contact with customer because you keep upgrading the product and keep bringing services to the customer. So that's the first aspect, like this customer intimacy. The second thing is that you can generate recurring revenue. So these manufacturers usually they're trying to sell you services or maintenance and so on. That's their attempt today to get some recurring revenue. But with servitization, this can be really something that happens during all the life of the product. And it can be also materialized by applications or software application that you can have on your product and provide some additional services, some additional customization for the end user. And that's the benefit for the manufacturer, but there is also, of course, a benefit for the consumer. As we all see with our mobile phones, if Everybody likes smartphones. That's because you have all these apps that can help you customize your experience and get more of your product. And that's what is going to happen to more or less all products.
So, Semir, with AI, connected systems, and similar demands on edge processing, what are your recommendations for how embedded developers can keep up?
Yeah, we talk about servitization. Of course, it's a big constraint for the developer, the engineer that want to develop the system. Then we need lots of software, some software resources. And then you can bring all the innovation that is coming as well in terms of AI and connectivity. And now you have like 5G, you have Wi-Fi 6, all these things. So I think the most important thing for the developer is really to make sure they maximize the use of their hardware resources and they don't over design. And this is very important because all this model works with model of servitization, and this new innovation works if it has the right price point. So it's important that take advantage of the technology that enable them to optimize their implementation and not over design, not go for, I would say, a mobile phone for every device. I say every device is a mobile phone, or every device is I would say, a Raspberry Pi, for instance. That would be completely overkill. So they use the right software technology to make use of this innovation, make use of AI, make use of connectivity, but still have a very efficient implementation. So for instance, the software platform like MicroEJ that we develop is very optimized for embedded devices. And we offer more or less the same services as a rich operating system, as a very advanced operating systems with a very small footprint, with things like virtualization, containerization, and also integration of all the major functions that you need for an IoT product.
Okay, so talk to me about MicroEJ's take on containerization for embedded in particular.
Yeah, sure. So as I mentioned, so MicroEJ, we are a software platform developed especially for the Internet of Things and for embedded devices. And what we bring is virtualization and containerization for small devices. If you think about containerization, it was really the backbone of success of cloud native technologies. All the cloud-based systems are based on some kind of virtualization and containerization, like Kubernetes and Docker, for instance. And basically, the cloud people, what they do, they develop microservices that are independent from the hardware and are very flexible and very portable. So this is what you want to achieve for embedded system, especially in the era of servitization. You want to develop a device that is software defined, that is very flexible, very portable, that with some hardware independence from the hardware. So your software can be really disconnected from the underlying hardware. And that's come also with agility in development, and also a product that is evolutive and fit the usage of the end customer. And so our take on that is that let's take all this technology, this concept, let's say this concept and benefit that are already successful in the IT world and the cloud world, and make them available for the embedded space. So we started from the ground up, instead of starting from, let's say, cloud technology and trying to feed them with I would say, with hammer in the small devices like some people do, and it really does not work. We started from the ground up, from really the embedded devices. So in fact, our very first implementation was on an 8-bit processor. It was a very long time ago. Now we support all kinds of 32-bit processors, from, let's say, microcontroller type of processors, from Cortex M0 up to Cortex M7. We even support Cortex A class of products. And we built a very optimized container. We call it the MicroEJ V, Virtual Execution Environment, that also allows containers within the container. So we have the full benefit of containerization and virtualization within the footprint of a very small device, very small embedded device.
Okay, Semir, so let's talk about CES. So what did MicroEJ bring to CES this year?
Yeah, so it was a very exciting CES, and we had lots of traffic at your booth with many people coming and looking at our demos. So, for instance, we had demos with customers. We have the Polar Watch. It's a smartwatch manufacturer, and they're using MicroEJ. We had also a smart cooker with Moulinex, which is an SCB company, one of the small appliance manufacturer in the world. We had another demo from our customer, Landis& Gear, for a smart meter, which is a very smart electricity meter that connects to the cloud and can upload services and applications. So it's a very good example of servitization. And as well as some other demos, like another one with Decathlon, which is a bike with a bike controller, and also demo in the industrial space with Schneider Electric, which is one of our partner also. So these are the customer demos, just showing the breadth of application that MicroEJ V can support. And then we had also some very nice demos with partners. For instance, one of them is NXP, the semiconductor company. We had the cellular modem demos with Telit and Thales. So this is more for the engineers, really how you can connect to a cellular network and how you can use the container to build application without disrupting the cellular connectivity. And then in terms of AI, we also had a demo with Ozone, which is an AI company and partner that provide image recognition and time series analysis with AI. And we showed this demo showing how you can use this camera, doing some recognition on the playing cards with MicroEJ. And MicroEJ used as a container to enable the integration of the application. So yeah, lots of demos, lots of very interesting partners and customers. And overall, in fact, a very successful CES with central theme was software-defined everything. It's kind of an illustration of what we are doing with these partners and with these customers. We are enabling them to build software-defined product and software-defined things.
Excellent. Okay, so one last question here, Semir. How do you think embedded teams can do more to build sustainable products and green software?
Yes, as I said at the beginning, sustainability is very important now in top of mind, in fact, in many consumers and many companies as well. So it's important and it's a challenge to reach sustainability. But the best way to address sustainability is to design very efficient products, and very efficient in two ways. The first way is from the bill of material point of view, the cost of your product, because more or less for consumer product, 80% of your CO2 comes from building of the product because they have short lifespan. If you look at the industrial product that have a longer lifespan, usually 50% is about production of the product and 50% is about life of the product when you would speak about power consumption. So you need to minimize both the cost of the product, the bill of material, and you need to minimize as well the power consumption. And the best way to do that is, as you said, to have an approach of green software, which means that you don't over-design, you don't take the shortcut in terms of product design and software enablement. So for instance, it's tempting to use very big processors with high performance OSs like Linux because it's just easy. But usually this results in very costly and power hungry device. So it's better to start with optimized solutions like MicroEJ, for instance, and build your product from efficient electronics using microcontrollers and doing just what you need to design a product and provide the service that you want to provide.
Excellent. All right, Semir, it is time for your off-the-cuff question. Now, I know you will have an opinion about this one. So, Semir, if you could have one meal right now, it doesn't matter if it's on the other side of the world, you need a passport to get there, the restaurant is closed. Semir, what would you have?
So if I could have a meal right now, so I will tell you, and it's personal. In fact, I'm a French, as you can hear, but I'm also from a North African origin. So my father is from Tunisia. And one that I would like to have right now, it's a very nice couscous from Tunisia. And I know it's very difficult to find. I'm living in the US. I live in San Francisco. It's obviously impossible to find here. So yeah, that's one I would like to have really. And I hope I can get it someday.
Excellent. Well, Semir, I think that's all I have time for today. Thank you so much for joining me.
Okay, very good. Thank you, Amelia. Thank you very much.
Keeping with our smart theme this week, what if a tattoo could tell you if you were stressed? An electronic tattoo, that is. Let me introduce you to a new e-tattoo developed by researchers at Texas A&M University and the University of Texas at Austin. They have developed a new graphene-based e-tattoo that uses electrodermal activity, or EDA sensing, that attaches to your palm, connects to your smartwatch, is nearly invisible, and can tell you when you're stressed out. So, this kind of EDA sensing e-tattoo didn't happen overnight. Nansu Liu, professor in the Department of Aerospace Engineering and Engineering Mechanics, and the leader of this project, along with her Texas team of researchers, have been working on the advancement of wearable e-tattoo technology for many years. But what they've done with this new palm-based e-tattoo is super cool. Okay, so let's back up a second. Current palm monitoring technology isn't that great. The electrodes are bulky, they're very clearly visible, and can fall off quite easily. And when these EDA sensors are applied to other parts of the body, they just don't give that good of a reading. Now, there has been other research studies along these lines, but these studies used nanometer-thick straight line ribbons to connect the tattoo to the reader, and really couldn't handle the strain of constant movement. So, what makes these new e-tattoos so special? Well, first, this team used graphene as their base material because of how thin it is and how well it can measure electrical potential from the human body, which is crucial to the accuracy of these kind of readings. And then there's the secret sauce. This team discovered that they were able to successfully transfer data from the e-tattoo on the palm to a rigid circuit. And in this case, that was a commercially available smartwatch. By using a serpentine ribbon that has 2 layers of graphene and gold that have been partially overlapped. By snaking the ribbon back and forth, it can handle all of the strain that comes along with the movements of the hand, of everyday activities like holding a steering wheel while driving, opening doors, running, etc. And get this team of researchers was actually inspired by virtual reality and the metaverse for this research, because VR is used in some cases to treat mental illness. However, the human aware capability in VR remains lacking in some ways. Professor Liu says this: "You want to know whether people are responding to this treatment. Is it helping them? Right now, it's hard to tell. But maybe these new e-tattoos can help." Super cool, right? So if you want even more information about these new palm e-tattoos that can tell when you're stressed out, I've included a couple links in the YouTube description for this episode and on the associated fish fry page on EE Journal as well, including a link to the research paper called Graphene E-Tattoos for Unobstructive Ambulatory Electrodermal Activity Sensing on the Palm, enabled by heterogeneous serpentine ribbons. Hey, have you checked out EE Journal on social media yet? Well, you should. You can find us at facebook.com/EEJournal. If you're into Twitter, you can monitor our tweets at EEJournalTFM. And don't forget, if you would like to follow my personal Twitter account, check out Amelia D 1978. And hey, if LinkedIn is more your thing, I completely understand. You can follow us or me on LinkedIn as well. And we have a YouTube channel, youtube.com/EEJournal. Folks, it is chock full of all kinds of techie videos, including our very popular Chalk Talk webcast series hosted by me. And you can subscribe to our EE Journal YouTube channel as well. Also, by clicking the links below the player on this week's Fish Fryin' page, you can subscribe to this here podcast through Spotify, Podbean, or Apple Podcasts. And remember, if you'd like to further support this podcast, please leave me a review on that podcasting platform of your choice. Also, if you'd like any further information about the stories covered in today's show, just head on over to eejournal.com and look for this week's Fish Fryin' page. Thank you everyone for tuning in. If you know of any cool new technology or heck you just want to chat, shoot me a line at Amelia, that's AMELIA, at eejournal.com, or post a comment on our forums on EEJournal. For the week of February 17th, 2023, I'm Amelia Dalton, and you've been fried.